Biosensors are becoming a big deal in medicine. These are sensors that are attached to someone's body, and when a current is run through them, can sense a change in the person's body. The difficulty is that these are usually made of polymers like rubber, and ever more so, there are lots and lots of them contributing to medical waste, filling up our landfills.
A key part of the problem is that medical devices are often designed to be single-use and thrown away to minimize the risk of infection. This includes digital medical devices like electronic drug delivery patches. The most common biosensor used in the UK is continuous glucose monitoring for diabetes patients. At the heart of the problem are the materials used in the electronics, the fiberglass reinforced epoxy resin in printed circuit boards, the heavy metals like lead, cadmium, and arsenic, and other toxic chemicals. These can cause cancer, neurological damage, cardiovascular illness, and respiratory diseases.
This leads me to a question. Is there a way to make a biosensor that's flexible and conductive and can be disposed of without any harm to the environment? Well, Ming Dong and Dimitri Papageorgiou at QueenMary University have done just that, using starch from something similar to potatoes. Why do they want to use starch? Because starch is readily available, it dissolves easily without damaging the environment, and it can be made flexible.
Starch is a natural polymer of glucose molecules and is composed of two main structures: 10 to 35% amylose, which is linear, and 65 to 90% amylopectin, which is branched. A solution of pure starch will dry to create a firm bioplastic, but it's brittle because the chains line up too closely. To make it more flexible and useful, a plasticizer needs to be added to separate the chains. In this case, it's sorbitol.
What they did was to make a solution of starch and then impregnate that with titanium.
And this is no ordinary titanium. They used an exotic two-dimensional material composed of titanium and carbide, a class of compounds called Maxenes. These were discovered back in 2011 and hold a range of useful electrical, magnetic, optical, and mechanical properties that make them attractive for use in energy storage, sensing, and photonics. Titanium carbide Maxene is also water-soluble, and when mixed with starch, it adds pressure-sensitive electrical conductivity to the material.
When it's on a surface and is bent, the induction in that area changes, so the bending can be sensed, thus a biosensor. So they made these strips and tested them on different parts of subjects' bodies to see how they respond. And indeed, they could measure movement in the person's body.
The strips could detect the throat moving during talking, the heart pulse from the wrist, and breathing motion in the chest. These have obvious applications in medical monitoring, and body movement measurements can be used for sports training. The Maxene impregnated film could also detect touch, which suggests it could be used for touch screens as well. All in all, this is pretty impressive, but that's not the end of it.
By using chips, they have managed to make dissolvable sensors, and they showed this by burying the sensors in soil and leaving them for a month. And as they dug them up throughout the days, they could see that progressively they were being degraded by regular soil bacteria. But Greg, wait! You said these had titanium in there. Shouldn't that just pollute the groundwater? It turns out the titanium oxidizes and goes into a form that doesn't hurt anything.
This technology could be applied to other types of electronic devices, replacing plastic circuit boards with biomaterials. And that's important because electronic waste is the fastest growing waste stream in the world. In Europe and the US, we throw away on average around 25 kilograms of electronic waste per person. Over 50 million tons globally per year. And with all the harmful chemicals that this releases, it makes electronic waste one of the biggest environmental health risks of the 21st century.
Hopefully, we will have biosensors that can just be buried thrown away without causing any further problem. And now, between the question and the answer, we know are the really tasty bits. I guess we could call it a computer chip, or crisp. It doesn't really work in British English. Stupid.